Welcome back to our second lesson on programming with Greenfoot. Greenfoot is a programming editor that uses Java and the power of object oriented programming to make simulations and games and animations. So today I want to dive a little bit deeper into how Greenfoot works and to make a more interesting kind of simulation. So I'd like you to start a new scenario. So if you go to scenario and select new Java scenario, and I want to call this walking dog. So I'll just call it walking dog. I'll use an underscore, but you don't want to have two words. Okay, so you can see that we automatically has to make a subclass of world or else it can't even make this graphics in the center. But today I want to do a little bit of work in the my world. So let's double click on it. First, we're going to put a description. This is going to be a world for a dog to walk around. And I'm going to call this class, let's change the name of the class first. We're going to call this class neighborhood. All right. Now we've got our neighborhood, or you can call it block or whatever you want, because it's going to be a block in a neighborhood. And I'm the author, so I'll say Jed Wilshire. You can put yourself as the author of yours, of course. And the date is, I'll just do version 1.0. 1.0. Okay. So we need to make sure that this and this matches. The constructor of a class has to have the same name as the class itself. And I want to make a square scenario today. So I'm going to, I don't need that comment anymore. So I'm going to change this. Let's go ahead and open up the world class. Remember, it just brings up the documentation. We don't need to see their private stuff anyway, right? We need to look at how to use this. So the world has two constructors. When we call super, we're calling the constructor of the class right above us. As you can see over here, neighborhood is a subclass of world. So this is the constructor I'm calling. I click on it to get more details. Constructs a new world. The size of the world in number of cells and the size of each cell in pixels. So the last number says if it's 1, that means each cell is 1 pixel. And the width and the height will be how many pixels. Excuse me, how many cells. So if I had a cell size that was 4 pixels, then that would be a bigger world if I had the same width, because it would be each cell would be that many pixels. So that said, let's go here to neighborhood, and I like the 1 pixel, but I'm going to do 600. Okay, so this is going to be a 600 by 600 world. Okay, the next thing I want to do is I want us to create a grassy area that will define our neighborhood. Okay, you can add houses to yours. You can add all sorts of things. You can. I'm gonna just make a grassy area, but you can have a grassy area. You can have houses. You can have lots of different ones. But for now, just for this video, and I hope you will improve on it, let's just make some grassy area. So I'm just going to take this opened up paint. You could use Piskel if you want, online if you know about that. Just any kind of paint editor. And I'm going to just fill this whole thing with dark green. And then I'm going to go here to this resize. And the resize, you want to uncheck maintain aspect ratio if you're doing this. So I can set it exactly what I want. So I want to set an exact number of pixels at 100 by 100. So that means I could fit 6 of these sideways and up and down. I got basically I'm making a grid here. Okay, so I've got that. All right, and I'm just going to save this as a PNG called grass. Okay, and I just saved it to my pictures folder. Don't need to worry too much about that. When you add pictures to Greenfoot, it will automatically take a copy of it and move it into your project directory. It has a little sub folder called pictures. Okay. So now that we've got that, we can add a class. So let's go. We're going to make it an actor. It's not going to be an actor that moves around. It's just going to be some scenery, but it'll also be something we want to interact with. So I'm going to make a new subclass called let's just call it grass, okay? And I looked through here. I didn't see anything that I particularly wanted. You could get houses and things like that, but I really wanted this green area, okay? And I can always add houses on top, just based on the order that I add them. But that's why I decided to make my own image. So I go to this, I don't know if you saw it, I go down to this little gear looking thing, and I say import from library, and I go to, I saved it in pictures. There it is, there. And now I've got it. So that's going to be my selected image for this grass. All right. So now let's go to our neighborhood and let's add some grass. So the way that you create an object, now remember the class grass is a class used to create grass objects. I have one class, but I can create many objects with it. Is what we use what's called the new operator. So I'm going to create a grass object here in the neighborhood constructor. So it's grass. That's the type. So when you create a variable in Java, we had an int, a string, a double, a grass, whatever it is, you have to type it first. You have to tell Java what it will be. And mine is of type grass. And so I'm just going to call this grass1. And I'll say new grass. And this is where excuse me, I'm going to go back and say that again. When you create, grass1 is the name of the variable, but I'm going to create an instance of a class. You do that with the word new. New means, hey Java, I need a new copy from this class. And then you put the class name. Remember, that's also the name of the constructor. Let's open up the grass class and take a look at it. Notice it doesn't have a constructor. All I see is this method act, which we won't even be using anyway. But it has to be there, though. So I will say public grass, and I'll leave it blank. And all I'm going to do is call the super constructor in actor with no parameters. So remember, though, Java will always make this constructor for you. So I didn't have a constructor. You know, I mean, I just came in here and wrote it, right? I didn't have one. But what I'm showing you is that when you don't write a constructor in Java, Java writes one for you, and that's the code. It'll be just a parameterless constructor with a call to super that has no parameter, which is actually exactly what I want here, because I just want to call the constructor in actor. Let's open up actor and take a look at that. In fact, that's the only constructor they have, is one that has no parameters. So no big deal there. But what does that tell me? That tells me when I call the constructor here, I don't put anything in the parentheses. Okay? All right, now I want to add it to my world. So remember, neighborhood is a subclass of world. So I inherit every method in the world class. Whenever you call a method that is either a method you wrote in the class you're working in right now, or a method that is in the superclass, or any superclass that you have, you just call it directly. You don't have to call it on an object. So I just say the name of the method. So let's go to the world class and let's find a method that allows us to add objects. So we're going to scroll down and look, and I hope you realize I'm not memorizing any of this stuff, and you don't have to memorize anything like this in my class. You just have to be able to read the documentation. There it is, add. I figured it'd be something like add, right? Add object, and it takes an actor and an X and a Y. You can probably guess what it does. So actor object, the parameter, that's the new object to add, and X and Y is the X coordinate where I want to add them. Notice it says you have to add an actor, but I'm trying to add grass. Is that going to be a problem? Well, look at my subclass here. Grass is a subclass of actor, which means grass is an actor. And they always want to give you the option to add things in the most general way possible. For example, if I was going to try add shapes, and if I said you can add, but it has to be a rectangle, would that mean you could add a square? Of course you can, because a square is a rectangle, right? So in this situation, it doesn't bother me at all that you have to be an actor, because my grass 1, it's a grass, but it's also an actor, because all grass is actor. So add object. Grass1 is the object's name I want to add, the variable name. And I'll put 0, 0 for the location. And let's see how it turns out. Okay, that looks pretty good. I just want to click on it and drag it around to look at it. Oh, you know what happened? It looks like it just put it half of it. Well, that's because the location that it adds is the center of the object. So I'm going to actually add it at position 50, 50. All right, let's take a look now. That looks a lot better. All right, our window is 600 by 600. So I want you to try and add some grass in each corner right now. Pause the screen and see if you can't add grass perfectly in each corner. Okay, let's see how you did. Hopefully you said grass 2 equals new grass. Then add object grass 2. And if I'm 600 away, then I need to be, if I'm 600 pixels to go all the way to the right hand side, I'm just going to make it 550, comma 50. This should be, remember the upper left hand corner is 0, 0, so this should be in the right hand corner. So because I went over 550 from 0, and I went just, and I kept it down to standard 50. Okay, so I keep opening on the wrong thing. All right, so then you could make some more, right? Grass 3 equals new grass. Add object grass 3, 550. I'll do 50, comma 550. That should be in the bottom left. Then grass 4 equals new grass. And I'll add that object to 550, comma 550. All right, and there we go. Well, it turns out you can actually add objects very quickly by right-clicking on it and saying new, selecting new grass, and then simply placing them wherever you want. So I'm going to place mine here. Then I'm going to hold down Shift, because if you hold down Shift, then it automatically gives you another copy of the class you just made, and then I'll click and let go of the Shift after I click. I'm going to add another one here. And I'll add another one here. Now I want a nice grassy area in the middle for my, what will be, I'm picturing a park or maybe a courthouse. There we go. That's what I'm looking for. Now, if you right click, well, let me move that down a little bit. That wasn't quite in the right place, so I'm just going to move it a little bit. If you right click, you can actually say save the world. And let's see what that does when you say save the world, because if I make any changes, what's going to happen is all of this stuff is gone. I'll have to add it all again over and over and over again. Oh, look what happened. It created a method called prepare for us. The prepare method is a method that is called right here. They add it, so they're adding a lot of code for us, aren't they? They're calling prepare, and look what it's doing. It's doing almost exactly what we did. But if you look at the numbers, I don't know about yours. Mine aren't actually all that right. You know, it's kind of hard to get it in just the right place. My math and my dividing and adding and subtracting was a lot more accurate. It was just more time consuming. And that's kind of a give and take with graphical user interfaces like this, where they allow you to drag and drop and then it auto fills in code. It's very useful. It's used a lot in the real world of programming, but it's not always exactly what you want. You sometimes got to go in there and you've got to be able to read that code. You've got to be able to manipulate it. One thing I do like is that, didn't you think our constructor was getting a little crowded? The constructor's purpose is to do, quite simply, the construction of the world. If you have to do a bunch of coding work, you need to put that in its own method, which you can call within the constructor, which is exactly what they did. Remember to call a method that's in the class you're working in or in the superclass, the class you extend. All you do is say the name of the method. So all they do is say the name method. Prepare. So I'll tell you what. Let's take their advice and let's move this down here. Now this is going to cause a problem because we have multiple things called stuff. So I'm just going to call this. I'm just going to renumber them. Actually, you can try and fix it if you want, but there's not that many of them. It would just be way too difficult for me. Oh, but you know what? Now I got to go in and I got to change all of these different things. Okay, you're right. That is a problem. Grass 5. That's going to be grass 6. That one's grass 7. That one's grass 8. That one's grass 9. I probably should have just started over and deleted mine and went back and added them and resaved. That would have been probably smarter. But, well, that's okay. Well, you'll notice that they've also got a set location. Do you see that? That set location is when remember when I clicked and said I didn't really like it and I moved a little bit? Well, let's get rid of that for now. Because I don't want to put things down and then remove them. So let's see how that does it now. Okay, that's pretty close to right. But it's not perfect. Let's fix it. I love the 50, the 550. So everything that's close to a 50, I'm going to make exactly 50. Let's see if there's anything like that. Well, no. But I do see a 550 and a 299. I bet that's supposed to be 300. And I bet this 305 is supposed to be 300. 250, probably then 250 here. So I'm just kind of squaring things off. And I find that I'll make that 250, 350. 337. Let's try 350. 250, 350. I don't know if this will work or not. Oh, that looks a lot cleaner, doesn't it? So there you go. That's the auto fill in, but I think the more you code, the more you're going to want to have complete control over where things go. But it is nice that you can do it. All right, so we've made a world. Let's make someone to interact with this world. Oh, but you know what? I want to add a background image to my neighborhood. Let's go to the neighborhood, actually right click on it and say set image, and let's choose one of these backgrounds. I want these to be like streets, but maybe brick streets? All right, this will take just a second. I may need to reset, actually. Oh, look at that. Now I got a little brick pathway. There were lots of different ones you could choose. If you don't like that, you could, there's lots of different backgrounds to choose from, but also maybe make your own background, right? So there you go. Okay, so now that I've got my little grassy areas on my nice, hip brick street, I'm going to make a dog. So I'm going to right click on actor and go to new subclass. And this is going to be called dog. Now it turns out that they don't have a dog. So you may have to come up with your own dog icon. But they have some things that look similar to a dog, like a polar bear or a pig. But I like this thing. And I don't think it's a bear. I think it's a wombat. I think I actually saw that in the Greenfoot official documentation. Apparently they are big on wombats. So we're going to use a wombat as a dog. Feel free to call your class wombat. You can do anything you want with it, actually. And what I want to do is I want to make my wombat able to move around. So let's open up the wombat. And I'm going to, again, I hate having these things on different lines. I have to do that. All right, so what I want my wombat to do is to walk around. And we could put our description. I'll put my name here. I gotta get my documentation already, right? Jed Wilshire, this is version 1.0. And so when the act method is called, I want my dog to move around. But you know what? let's um, let's write a method called move and turn, because I don't want everything in this act method. This act method could get really big because I want this dog to do more than just walk around the screen. I want us to be able to add different things it can do. So I'm going to write a method called move and turn. How do you call a method from within the class you're working in? You just say the name of the method. So there we go. Public, it must be void because I'm not returning anything. If I were returning something, I would have to catch it. Maybe if I was returning an int, I might say int x gets the what move and turn returns, but I'm not. Okay. So what I'm going to have this dog do is walk until it runs into something and then turn when it hits something. Okay? So I'm going to say, first thing I'm going to do is I'm going to figure out if it has run into some grass. So I'm going to want to call a method that gives me anything the dog is intersecting with, any other actor. So let's take a look at the actor class again. If you don't have it up, just double click on actor. And here is right here, these are the methods that you can use. You can get your neighbors. You can get things that offset, like, 5 cells away in one direction or another. You can get objects in a range. You can get lots of objects or just one. Well, right now we're going to do just one, and it's called get one intersecting object. Let's click on it. First of all, notice it's protected. In our class, we don't have to worry about public or private. Protected means you can call it from subclass. It's basically like public, except for I cannot call it, say, from my neighborhood class. You should only ever call get one intersecting object on an actor, because you're asking, does that actor intersect with something else? So protected, just like private, it's another way to make sure that you don't screw it up, because you don't want your code to completely fail. This is just a good way of making sure that you do it right. So get one intersecting object is the name of the method, and look at the parameter, java.lang.class, and it says CLS, class of objects to look for. So you have to tell it what you are looking for. Are you looking for another dog? Are you looking for a grass area or something else? So that's very helpful. Also notice that it returns an actor. Well, it's supposed to return what I'm intersecting, but if my dog is intersecting the grass, I wish it would send me back grass. But you think about it, it can't. They wrote this method before they ever gave me a chance to write the grass class. So the only thing they could do is give me actor, but that is totally cool. Because what is grass? A subclass of actor. So grass is an actor. So it's no problem at all. They always want to return whatever I have to subclass, so it'll work for anything I ever do. Okay, back to dog. So what I'm going to do is I'm going to have to type this as actor, and I'll just call it grass equals, and do you remember the name of the method? It was get one intersecting object. And since I could be intersecting lots of different objects, some of which are things I just want to fly right over, other things I don't, you have to tell it what kind. So I'm going to say grass.class. Am I intersecting an object of grass.class type? Now, remember, this method returns something, right? Because it doesn't say void there, it says return. So that's why I have something to catch it with. I made a variable called grass to catch it. Now, it turns out, though, that grass may or may not actually have something in it. If you're not intersecting anything, the documentation does explain it will return null if you're not intersecting it. Null means nothing, empty object. I have an object type, a variable named grass, but if there's nothing in it, it's null. So I'm going to say an if statement. I'm going to say if is at edge or is on edge? I think it's is at edge. So if we're at edge, we're going to turn. So if we're at the edge of the screen, we're going to turn. Or, that's the double pipe, or grass does not equal null. So if grass is not equal null, that means that this returns something that actually was real grass object. That means we're hitting grass. Well, what I'm going to do is I'm going to turn 90 degrees. Actually, let's go back up. I want to make it to where we move 2 pixels first. So we're going to move 2. Then when we need, if we run into an edge or grass, we'll move back. And this is not a problem for the animation because this entire act method and all the move and turn is all going to be done in between flips of the frame. So yes, the logical position will be moved 2 forward. Then we'll see that it's bad, so we'll move 2 back where we were, so that we're not like stuck in a wall. And you won't see any of that because it's not actually drawn until this method is completely calculated. So that's totally fine. And we're going to turn 90 degrees. So we're always going to turn to the right. All right, I think that's what I want. So let's do that. Let's compile it. And let's get a dog. And let's run it. All right, so my dog should be avoiding walls and grassy areas. And because I have them constantly turning right and I have that little offset place in the middle, I'm hoping that we see this dog go to lots of different places. Kind of a neat simulation. You can see the different places that he goes at different times. Well, I don't know about you, but that is pretty satisfying. All right. So that's all I have for this lesson. I think that's enough to chew on. In our next lesson, we're going to keep working on the walking dog scenario. But for your assignment, I'm going to have you make something similar, but a little bit different. I want to make sure that you're applying this stuff and practice creating your objects in your world constructor and adding the different places you need. You can also use the Save the World feature, but you've got to be able to understand how to create objects with a new operator. So until our next lesson, when we're going to add more things for our dog to do as it walks around, take care and have fun coding in Greenfoot.